Time you work in one of these old tube radios or any tube equipment, there is high voltage all over, so that's why I put this reminder.
Hello, I'm here with another radio. This is a tube radio and it's a clock radio. This is the type of radio I always wanted to have one, and I managed to get one in a really good condition. The exterior is really good shape, no cracks, no stains, no problem with the yellowing, so it's really nice. And acrylic here for the clock, it's also in perfect shape. It has some like marks here, but I think it's original from the plastic itself. It has the original knobs. Maybe this is a bit yellowed with time, but I won't do anything about that. And I'll show you. Maybe this is the back side of the radio. The model number is RHD10Y. Mine is the white one, and that's the tube line out. It's a hot chassis tube, solder radio, and it's in really good shape. I've already opened it here. It's very simple. I have the cable, I have the tubes. I remove them here. I have all the tubes here, and I remove them for moving the radio around. So I can see that the radio has been recapped, but I will replace all this and some overheating here. Maybe this is normal for the age of the radio, and there is still a wax capacitor, so that has to be changed. So what I will do here is I will remove everything, and I will go over all the cigar. Here's another capacitor here, wax capacitor. So I will change all the capacitors, and I think this radio looks like there is nothing wrong with it, so I think it will run with no issues. And I hope the clock also. I haven't powered it up, and I won't power it up until I replace this capacitor. So I have to measure the tubes. Everything here is really nice, so I think this radio will be working just fine. Sorry. The problem is that this radio is 110 volts, 60 hertz for the clock to work correctly, and here we are 220 volts, which that's not a really big problem, because we can put a very small step down transformer, but the frequency in the line is 50 hertz, so the clock will go slower. So I have to think about that a little bit. I have a couple of ideas there, but that's another project. Okay, I removed the PCB from inside the cabinet. This is a PCB based radio, one of the earliest PCBs. They're quite fragile, but it's there. There are no schematics online for this radio. There is a guy here that has been working with one of these, and as you can see here, it's one of these, so I could check to see if there were some things that weren't original. For example, this tube socket, which is a different type. At first I thought it was replaced, but no, it's original. His radio has that same type of socket too. So everything looks to be original except these two electrolytics, which of course they were replaced at some time due to failure of the original. That's normal. Okay, I drew out the schematic. These are my first notes. Then I did it in a more tidy way. But then I was trying to find some information on the schematic for this couplet, which is like an integrated, it's the most of the circuit between the audio detector and the audio output tube are integrated into this inside this ceramic package with 7 pins. There are different models of this with different number of pins and everything. So looking for information of this couplet thing, I managed to find a schematic online from someone that was making some notes on it, that it's like exactly the same that the one for this radio, although it's not exactly for this model of the radio, but most probably they use the same PCB for different radios. This also has like the motor for the clock and the switch and for the alarm, and so this is the volume knob is exactly the same, and we have the couplet here with all the parts inside here, so it has the 7 pins. Here's another image I found on the internet, which it's a more zoomed image of only the part of the couplet with all the components inside. So what I think is happening here is that some of these values have drifted, and that capacitor, which is the coupling capacitor, as you can see it goes directly to the grid of the output tube, is leaky. So I measured some resistors here and the value have drifted, and maybe this is leaky. So, and that can be consistent with the problem I have here on the tube itself. This is the output tube, which is all the PCB. It's all overheated here. So maybe the cause of this is that the coupling capacitor inside the couplet is it's bad. So the way to really know this is I will desolder this from the PCB and measure it by itself, to be able to isolate any other resistance, because I can measure the resistance between 6 and 7, for example, but I don't know. There shouldn't be any resistance between 6 and 7 if this is exactly like this, because well, maybe something can go this way here, and I don't know. There shouldn't be any resistance between this and this. But the best way, I think, it's to desolder this and test it by itself to see what's happening. I remove the couplet from the radio and measure it by itself, disconnected from the rest of the circuit. The values I measured are all a bit drifted from the ones on the schematic, but they are all in the ballpark. They are not like really bad. The resistors are a bit higher. Here you can see it says 470K, and values, what I measured was about 530, something like that, 540K. But both resistors were in very similar value. It's not that one drifted and the other was. Also the capacitors, for example, this resistor was measuring about 8 meg instead of 6.8, and this one was really good. This one was 220 picofarad, perfectly there. And this one was, I think, a little bit lower, but the most important thing is that I measure leakage in all of these capacitors. Not these ones, of course, because I have the resistors in parallel, but I measure leakage from 6 to 7, and I measure leakage from 4 to 3, and from 1 to 2,
and none of these capacitors were leaky. So although the values have drifted, I think I will reinstall the couplet in the radio and continue with replacing the caps and everything and test the radio, because I removed the IF coils and the parts that needed replacement because they were drifted in value. For example, well, of course, those two paper and wax capacitors that were there, of course, they were really leaky, and some resistors, a couple of resistors that drifted in value that I will replace. So I removed them in order to clean the PCB better. So I decided, well, I remove the resistors, the capacitors, and I also will remove the IF cans so that the cleaning solution won't enter and spoil the IF can. After cleaning the board, I've looked at it more carefully, and I realized that the board here, where the output tube was really hot for a long time, it's cracked. I think you can see there. And although the tracers are not broken, this is all darkened by the heat, so maybe it's a bit conductive. And what I will do here, and this will or come out very well or very bad, I will cut this part of the board out, and I will somehow place a new socket there for the output tube, which I think it's better because it will isolate a bit better the heat from the output tube from the PCB itself. So let's see what happens. Well, the result is much better than expected. First of all, it didn't break into pieces, and second, it came out really well. It's very solid, very well. I did a hole with the step bit and until the correct size, and then I removed from this socket the metal part of the top and solder it from behind. I had to make with wire one. There used to be a trace here, and I did that with some wire and soldered the tabs from below here, and it came out really well. And one plus of this is that the heat can be removed much better by convection. The cool air comes in just from underneath the tube instead from the sides, so it's a much nicer convection cooling there. So I'm really happy with this. So now the board is clean, it's nice, so I will start building it up again. I have to this is quite stiff. I think I have to put some oil in the bearing there, but I'm very happy with the result. I finished assembling the radio. I've installed, well, the socket as you saw, and then the rest of the components, the IF cans, and well, the new electrolytic capacitors. I drilled some holes so that they are aligned properly and they are soldered here correctly. This little capacitor there, this other capacitor here. I replaced the 100 ohm biasing resistor for this tube, which was a little bit out of tolerance, and also replaced this other 150 ohm biasing resistor for
for this, I think, yes, it's for the output tube. The 1200 ohm resistor, drop down resistor is fine, no need to replace it. And then I also replaced the 47k resistor that goes in series with the volume pod, which was, yes, way out of tolerance. I've reinstalled the couplet thing here and cleaned all the board. So I think it's ready for testing. Before testing, I will check all the tubes with the tube tester. I don't have replacements here, so if there is, I hope there isn't a bad tube, but well, let's see. And after that, to test it, I will need to reinstall it back into the chassis, because I have to solder all the wires in place. And I have to remember that I have to plug it into 110 volts and not into 230 volts as we have here. Okay, I'm in the process of aligning the IF cans. I've done it already with the function generator and the analog meter, and which makes things really simple or less difficult. I won't show it on camera because there are thousands of videos doing the IF cans alignment, and also I will check the RF section. The oscillator doesn't have any precision, but I will check it. The dial doesn't have any precision, so I will check it anyhow. I mean, it's very low resolution, because half a turn for all the dials, so it's something that I will check the antenna coil with the trimmer to see if the gain increases. But overall, the IF cans are now aligned.
Tengo que confesarles que es una de mis óperas predilectas. A veces no importa los argumentos ni nada por el estilo, sino que importa es la música.
Okay, the radio is working very nice. I'm very happy. I've aligned the intermediate frequency and the oscillator here, and also the antenna coil, and everything seems to be working really nice. The clock is working. I'm checking if I guess it depends on the line frequency, so I think this will won't work. Will work slower than it should, because of the line frequency here is 50 Hz instead of 60. So I'm checking that at the moment. But apart from that, the radio is working really nice. I've closed it here for the moment because I have to clean it inside the cabinet a little bit, but otherwise it's very well. I have to clean it here too, but the radio is working.
Nacía el pintor francés Paul Cézanne. En el año 1899 nacía.
Really good. Okay, I'm very happy. Thank you for watching.